Let's look at intervals of concavity. Let's say a graph is like this. So here if you notice, it is concave up. Here the curve is concave down. Similarly, you might have something like this. Then you have concave up, concave down, concave up. So based on this, let's look at solving some problems. First one, f of x is equal to minus x cube plus x square minus 3. Okay. Now, our first derivative will give us the slope of this curve at any given point. So f prime of x will be minus 3x square plus 2x. Okay. And if we take the second derivative, f double prime of x, that would give us minus 6x plus 2. And this will give us the slope of the slope. Now, if we equate it to 0, what do we get? We get minus 6x equal to minus 2, that is x equal to 2 by 6, that is 1 by. So what this tells us is that from minus infinity to 1 by 3, there is an interval of concavity. It doesn't tell us whether it is up or down, right? And it also tells us that there is another interval of concavity from 1 by 3 to infinity. Now, to figure out whether it is up or down, what we do is we look at a value, take a value of x which is just before or after these values. Okay, so let's do that. Here we have 1 by 3, that is, we have to take a value to the left of 1 by 3, which means we can take it as 0. So f double prime of 0 minus 6 times 0 plus 2, which gives us 2. And this is positive. Positive means this is concave up. And if we take a value beyond 1 by 3, so f double prime of, let's say 1, we get minus 6 plus 2, which is minus 4. Remember, the value itself is not important. What is important is the sign, whether it is plus or minus. Now, since this is negative here, it is concave down. Now, let's look at the second one. F of x is equal to x square minus 3. F prime of x equal to 2x. That means f double prime of x equal to 2. Now, whatever be the value of x, it will always be a positive number, that is 2. So that means our interval is going to be minus infinity to infinity. And it will always be concave up. Okay. Third one, f of x is equal to x square by 2 minus 3x plus 9 by f prime of x is equal to 2x by 2 minus 3. 2 cancel, so we have x minus 3. F double prime of x equal to 1. And again, whatever be the value of 1, it will always be, whatever be the value of x, it will always be 1. So that means the interval is minus infinity to infinity. And it is always concave up. Okay, fourth one, f of x is equal to minus x cube plus 2x square minus 3. Okay, f prime of x is equal to minus 3x square plus 4x. F double prime of x is equal to minus 6x plus 4. Okay, now let's equate this to 0. What do we get? We get 6x equal to minus 4, x equal to minus 4 by 6, that is 2 by 3. That means the intervals are going to be minus infinity to 2 by 3 and from 2 by 3 to infinity. Now let's pick a value between minus infinity and 2 by 3. So let's say we are taking up f of 0, f double prime of 0, which gives us 0 plus 4, which is 4, which is a positive number. So this is going to be concave up. Now f double prime of beyond 2 by 3. So let's take it as 1, which gives us minus 6 plus 4, which gives us minus 2, which is negative. So therefore here it is going to be concave down. Fifth one, f of x is equal to x square plus 6x plus 9. So f prime of x equal to 2x plus 6 and f double prime of x is equal to 2, and this will always be positive. So which means that the interval is minus infinity to infinity, and in this interval it is concave up. Now let's look at the sixth one. F of x is equal to minus x square by 2 plus 3. So f prime of x is equal to minus 2x by 2 and 2 cancels, which is minus x, and f double prime of x is equal to minus 1, which means that there is going to be a single interval minus infinity to infinity, and in that interval it is going to be concave down. Let's look at the seventh one, and this is going to be a little bit more challenging. So f of x is equal to minus x square by 3x minus 3, which can be written as minus x square by 3 times x minus 1. Okay. Now, the moment you see an x in the denominator, uh, you need to be careful. The denominator can't be 0, so which means x minus 1 cannot be equal to 0, which means x cannot be equal to 1. Okay, so which means the interval is minus infinity to 1 and 1 to infinity. And using the second derivative, let's see whether there are any other intervals. Okay, so f prime of x is equal to 1 by 3, we take it out. Okay, so we are left with minus x square by x minus 1. Let's differentiate that. We get x minus 1 as it is times minus 2x minus uh, minus x square as it is, and then the derivative of the denominator divided by x minus 1 square. Let's simplify this. 1 by 3 times minus 2x square plus 2x plus x square divided by x minus 1 square, which gives us 1 by 3 minus x square plus 2x divided by x minus 1 square. Okay, now let's leave it at this. Let's go for the second derivative. So f double prime of x will be 1 by 3, and now x minus 1 square as it is, and the derivative of the numerator. So minus 2x plus 2 minus the derivative of the denominator times 1, and then the numerator as it is. So minus x square plus 2x divided by x minus 1 square square. Okay, let's simplify it. We have a x minus 1 here, x minus 1 here. So let's take x minus 1 out. We are left with x minus 1 minus 2x plus 2 minus 2 times minus x square plus 2x divided by x minus 1 4 times. Now 1 of x minus 1 will get cancelled, and we have minus 2x square plus 2x plus 2x minus 2 plus 2x square minus 4x divided by x minus 1 cube and 3. So minus 2x square plus 2x square gets cancelled. 2x plus 2x is 4x. So 4x and minus 4x gets cancelled. And we are left with minus 2 by 3 times x minus 1. So this is our second derivative. And this doesn't tell us anything because we can't equate it to 0 because then x disappears. So the only intervals we have is at minus infinity to 1 and 1 to infinity. So intervals are minus infinity to 1 and 1 to infinity, which means we just pick up two values, one between minus infinity to 1. So which means let's take it as 0, minus 2 by 3 times 0 minus 1 cube, which gives us minus 2 by minus 3, which gives us a positive number. Now, from 1 to infinity, let's take it as 2. So, minus 2 by 3 times 2 minus 1 cube. 2 minus 1 is a positive number, cube is positive, so denominator is positive, which means it is a negative. So, that means this is going to be concave up and this is going to be concave down. Okay, so that was the seventh one. Let's look at the eighth one. F of x is equal to x by x plus 2. Again, denominator can't be 0, so x plus 2 cannot be equal to 0, so x cannot be equal to minus 2. So purely based on this, the intervals are minus infinity to minus 2 and minus 2 to infinity. Now, f prime of x is equal to x plus 2 as it is, then times 1 minus 1 times x divided by x plus 2 square, which gives us x plus 2 minus x by x plus 2 square. X cancels and we have 2 by x plus 2 square. Okay, f double prime of x gives us x plus 2 square times 0 derivative of 2 minus 2 times x plus 2, 2 minus 1 1 times 1 and 2 as it is divided by x plus 2 square, that is 4, which gives us minus 4x minus 8 divided by x plus 2 4 times, which gives us minus 4, and we get x plus 2 by x plus 2. So this and this cancels and we end up with the second derivative as minus 4 by x plus 2 cube. Here again, if you notice, if we equate it to 0, x disappears. So the only intervals we have is minus infinity to minus 2. Minus infinity to minus 2 and minus 2 to infinity. Now, let's pick some values. F double prime of, let's say, minus 3, right? So, minus 3 is equal to minus 4 by minus 3 plus 2 cube. Now, minus 3 plus 2 is negative, cube is negative, so negative, negative, positive. So, this is going to be concave up. F double prime of, let's say, minus 1, which gives us minus 4 by minus 1 plus 2 cube, which gives us, now the denominator is positive, so this is negative. That means this is going to be concave down. Okay, ninth one. F of x is equal to minus 3x minus 6 to the power of 1 by 3. Let's look at f prime of x. So that would be minus 1 by 3 times 3x minus 6 to the power of 1 by 3 minus 1. That gives us minus 2 by 3 times 3. And this and 3 cancels. Okay, this is going to be minus 3x minus 6 to the power of minus 2. Okay, now f double prime of x is going to be minus times minus plus 2 by 3 times 3x minus 6 to the power of minus 2 by 3 minus 1. That is minus 5 by 3 times 3. Again, 3 and 3 cancels, and we are left with 2 times or 2 by 3x minus 6 to the power of 5 by 3. Okay, now we can't equate it to 0, disappears, x disappears. One thing is here, something funny might be happening at x equal to 3x minus 6 equal to 0. So when this becomes 0, denominator becomes 0. So let's see what is happening. So 3x minus 6 equal to 0. So 3x equal to 6, x equal to 2. So most probably what is happening is that, it is going something like this. So the slope is vertical at this point. Okay, so that would be an interval minus infinity to plus 2 and 2 to infinity. Okay, so now let's see the concavity. So f double prime of, let's say, minus infinity to plus 2. So let's take it as 1. 2 by 3 minus 6 to the power of 5 by 3, which gives us 2 by minus 3 to the power of 5 by 3. The cube root of a negative number is negative, and an odd power of that negative number is going to be negative. So which means positive divided by negative will give us negative. And that means that this is going to be concave down. Now let's look at 2 to infinity. So let's take it as 3 equal to 2 by 3 times 3, 9 minus 6 to the power of 5 by 3, which gives us 2 by 3 to the power of 5 by 3. We don't have to evaluate it, remember. A cube root of 3 is positive, and fifth power of that is going to be positive. So, which means it is going to be a positive number. And that means that this is going to be concave up. Let's look at the 10th one. F of x is equal to 3x plus 3 to the power of 1 by 3. Very similar to the previous problem. So f prime of x is equal to 1 by 3 times 3x plus 3 to the power of minus 2 by 3 times 3. So 3 cancels. Okay, f double prime of x is going to be minus 2 by 3 times 3x plus 3 to the power of minus 2 by 3 minus 1. So minus 5 by 3 times 3. So again 3 and 3 cancel, and we have minus 2 by 3x plus 3 to the power of 5 by. Again, we can't equate it to 0, x disappears. But something funny is happening at x equal to 3x plus 3 equal to 0. So 3x plus 3 equal to 0 means x equal to minus 3 and x equal to minus 1. The intervals will be minus infinity to minus 1 and 1 to minus 1 to infinity. Now let's take some values. F double prime of minus 2 is equal to minus 2 by 3x is minus 2, no? So minus 6 plus 3 to the power of 5 by 3. Now the denominator is going to be negative. Minus 6 plus 3 is minus 3. Cube root of a negative number is negative, and fifth power of that is also going to be negative. So negative, negative, positive. Again, f double prime of, say, 1 is equal to minus 2 by 3 plus 3 to the power of 5 by 3. Denominator is going to be positive, so this is going to be negative. So therefore this is concave up and this is concave down. Okay, 11th one. F of x is equal to minus x plus 5 to the power of 1 by 2. Now, the moment you see square root, immediately you know that minus x plus 5 has to be greater than or equal to 0. If it is less than, then we get into complex numbers. Minus x has to be greater than or equal to minus 5. That means x has to be less than 5. Okay. So which means our interval is going to be what? Minus infinity to 5. Now let's differentiate. F prime of x is going to be 1 by 2 times minus x plus 5. Half minus 1 is minus half times minus 1, which gives us minus 1 by 2 times minus x plus 5 minus half. Okay, f double prime of x is going to be minus times minus is plus, 1 by 2 times 1 by 2 is 1 by 4 minus x plus 5 to the power of minus half minus 1. So minus 3 by 2 times minus 1, which gives us minus 1 by 4 times minus x plus 5 to the power of minus 3 by 2. Again, since minus x plus 5 is to the power of minus 3 by 2 is in the denominator, we can't equate it to 0. Okay. But we have our interval minus infinity to 5. So let's pick a value here in this interval. So let's pick say minus 10, or we can why minus 10? We can pick 1 also or 0 also. So f double prime of 0 is equal to minus 1 by 4, 5 to the power of minus 3 by 2, which gives us minus 1 by 5 to the power of 3 by 2. The denominator is going to be positive. This is negative, so this is going to be negative, which means this is going to be concave down. Okay, 12th one. F of x is equal to x to the power of 4 minus 3 x square plus 1. F prime of x equal to 4x cube minus 6x, and f double prime of x equal to 12x square minus 6. And here we can equate it to 0. So 12x square equal to 6. X square is equal to 1 by, no, 6 by 12. So 1 by 2. So which means x is equal to plus or minus 1 by root 2, which can be written as plus or minus root 2 by 2. Okay. Now let's see. Let's pick some values. Plus or minus is there. So minus infinity to minus root 2 by 2. And from minus root 2 by 2 to root 2 by 2, and from root 2 by 2 to infinity. Okay, so we have three intervals. So let's look at that. What is the second derivative? 12x square minus 6. Okay, let's pick some values. F double prime of, let's say, root 2 is 1.41 divided by 2. Okay, so let's take it as 3, which gives us 12 times 9 minus 3 square is 9 minus 6. That means this is going to be a positive number. Okay. Now let's look at between minus root 2. So let's take it as f of 0, which gives us minus 6. Right. So which is negative. And let's say f double prime of 3, which gives us again 12, 9 minus 6, which is a positive number. So that means concave up, concave down, concave up. So concave up, concave down, concave up. Let's look at the 13th one. F of x is equal to x cube by x square minus 4. Immediately we know the denominator cannot be 0. So let's see, x square minus 4 equal to 0. Cannot be equal to 0. So x square cannot be equal to 4, which means x cannot be equal to plus or minus 2. So as per this, the intervals are going to be minus infinity to minus 2, minus 2 to 2, and 2 to infinity. Now let's differentiate. So f prime of x is going to be 3x square times x square minus 4 minus x cube times 2x by x square minus 4 square, which gives us 3x to the power of 4 minus 12x square minus 2x to the power of 4 divided by x square minus 4 square. X to the power of 4 minus 12x square by x square minus 4. Now let's differentiate it once more. F double prime of x is going to be x square minus 4 square, denominator as it is, and differentiating this we get 4x cube minus 12 to 24x minus, now numerator as it is, and differentiating the denominator we get 2x square minus 4 to the power of no 1 times 2x divided by x square minus 4 square square, that is 4. Now let's see, x square minus 4 is common here and here, so let's take that out. So one of this and this will disappear, so we will have uh, x square minus 4 times 4x cube minus 24x minus 2 times 4. So 4x times x to the power of 4 minus 12x square divided by x square minus 4, 4. This and one of this gets cancelled and we end up with 4x to the power of 5 minus 24x cube plus 24 fours 96x and minus 16x cube minus 4x to the power of 5 plus 12 fours 48x cube divided by x square minus 4 cube. So now 4x to the power of 5 minus 4x to the power of 5 cancels. 24 minus 24 minus 16 is minus 40. Minus 40 plus 48 is 8x cube plus 96x divided by x square minus 4 cube. Now f double prime of x, let's equate it to 0. What do we get? This disappears and we have 8x cube plus 96x equal to 0. Let's take 8x out. We get x square plus 12 equal to 0, which means x equal to 0, and this would be x square plus 12 equal to 0, x square equal to minus 12, and square root of minus 12, we are not interested in complex numbers. So what do we have? Here if you notice, in the beginning we had arrived at this set of intervals. But now we also have one more value, x equal to 0. So that means our final list of intervals are going to be minus infinity to minus 2, minus 2 to 0, 0 to 2, and 2 to infinity. Okay. Now we have to look at the concavity. So let's look at f double prime of some values. F double prime of x is equal to, let me write down that, 8x cube plus 96x divided by x square minus 4. X square minus 4 cube. Again, remember, we don't have to really evaluate the entire. Okay, so f double prime of minus 3 will give us what? We will have 8 times minus 27 plus 96 times minus 3. So this is going to be negative, this is going to be negative. Okay, divided by minus 3 square. So this will become positive. So 9 minus 4 cube. This is a positive number. Cube is positive. So this means this is going to be negative. So that means this will be concave down. Now f double prime of let's say minus 1. This would be 8 times minus 1 cube is minus 1 plus 96 minus 1. So numerator is going to be minus, and this is going to be again minus because of this x square. Everything gets becomes positive. So here minus 1 will become 1 minus 4 to the power of 3. So negative. So negative, negative, positive. So that means in this interval it will be concave up. Similarly, f double prime of what are the next interval? 0 to 2. So let's say 1. This is going to be 8x cube. So this would be positive numerator, and this would be 1 minus 4. So this would be negative. So that means this is negative, which means this is concave down. And now finally let's look at f double prime of 3, which gives us a positive number in the numerator and a positive number in the denominator, which means this is going to be plus, and therefore this is going to be concave up. Now let's look at some trigonometric functions. F of x is equal to 2 sine x, and we are given the interval minus pi to pi. F prime of x is going to be 2 cos x, and f double prime of x is going to be 2 times minus sine x, which gives us minus 2 sine x. And equating it to 0, what do we get? Sin x is equal to 0, which means x equal to minus pi 0 pi. Okay, so the intervals are going to be minus pi to 0, 0 to pi. Okay, now f double prime of x is equal to minus 2 sin x. So let's pick some values. So let's say f double prime of minus pi by 2. This is going to be minus 2 sine minus pi by 2, which is going to be sine pi by 2. And sine pi by 2 is, here 2 is there. So 2 times 1 is, okay, now let's take f double prime of pi by 2, which is equal to minus 2 sine pi by 2, which is equal to minus 2 times 1, which is minus 2. So this is going to be concave up, and this is going to be concave down. 15th one. F of x is equal to minus cos x in the interval minus pi to pi. Okay, f prime of x is going to be minus sin x, which gives us sin x. And if we differentiate it once more, f double prime of x is equal to cos x. Okay, now let's equate it to 0. So when will cos be 0? When x is equal to minus pi by 2 and pi by. So our intervals will be minus pi to pi by 2. Sorry, minus pi by 2, minus pi by 2 to pi by 2, and from pi by 2 to pi. So we'll have 3 intervals. Now let's pick up some values. F double prime of let's say minus 3 pi by 4, which is between minus pi and minus pi. This would be equal to minus root 2 by 2. Okay, now let's look at f prime of 0. This would be equal to 1. And finally f double prime of 3 pi by 4. This would be minus root 2 by 2. So which means this is going to be concave down, this will be concave up, and this will be concave down. Okay, 16 one. F of x is equal to minus sine 2x. Again, in the interval minus pi to pi. Okay, f prime of x is going to be minus times cos 2x times 2, which gives us minus 2 cos 2x. Take the next derivative, f double prime of x, which gives us minus 2 cos x is minus sine 2x times 2, which gives us, and this would be minus 4, no, minus into minus plus 4 sine 2x. Okay, now let's equate it to 0, which would imply that sine 2x is equal to 0. And when is sine 0? When it is minus pi, 0 and pi, which means x would be equal to minus pi by 2, 0 and pi by 2. So the intervals would be minus pi to minus pi by 2, minus pi by 2 to 0, 0 to pi by 2, and from pi by 2 to pi. So we have these four intervals. Now let's pick some values in these intervals. So f double prime of minus 3 by pi by 4 is equal to whatever it is going to be a positive value. You can just check it out. Similarly, f double prime of minus pi by 6 is equal to a negative value. F double prime of pi by 6 is equal to a positive value, and f double prime of 3 pi by 4 is equal to a negative value. Okay, this is by 4. So which means this is going to be concave up, concave down, concave up, concave down. Now let's look at the 17th problem. F of x is equal to x plus 2 by x minus 1 square. Okay, immediately we know x minus 1 cannot be equal to 0. So x cannot be equal to 1. So immediately we have two intervals, minus infinity to 1 and 1 to infinity. Okay, let's see. F prime of x is going to be, this can be written as x plus 2 square by x minus 1 square. So the first derivative would be x minus 1 square times 2 times x plus 2 to the power of 1 times 1 minus x plus 2 square times 2 times x minus 1 times 1 divided by x minus 1 square, which is equal to x minus 1 common is there, x plus 2 is common. So x minus 1, x minus 2 is common. We are left with x minus 1 times 2 minus, this is x plus 2, not minus. And one of the x plus 2 is there, 2 is there, x minus 1 is out, divided by x minus 1 square, that is 4. So x minus 1 and one of this cancels. So we are left with x plus 2 times 2x minus 2 minus 2x minus 4. So 2x cancels, x minus 1 came. So we have x plus 2 times minus 2 minus 4 is minus 6 divided by x minus 1, which gives us minus 6x minus 12 divided by x minus 1 cube. So that was our first derivative. Now let's look at the second derivative. This would be, if we go through the whole process, we will end up with 12x plus 42 divided by x minus 1 to the power of 4. Okay. Now let's equate this to 0. What do we get? 12x plus 42 equal to 0. 12x equal to 42. X equal to 42 by 12. So that would give us 6 twos. By the way, this will be minus and 6 7. So x would be equal to minus 7 by. So here one of the intervals was one of the points was 1, and now we have another one. So our intervals are going to be minus infinity to minus 7 by 2, minus 7 by 2 to 1, and then from 1 to infinity. And now let's pick some values. So f double prime of 2363 point some 3.5. So let's take it as minus 4, which gives us what is that 12x plus 42. So 12 times minus 4 plus 42 by 12 minus 1 to the power of 4. So denominator will always be a positive number because of the even power. So we can ignore this denominator totally. Now 12 4 is 48, so this is going to be negative. F double prime of minus 7 by 2 to 1. So we can as well take it as 0. So this will be 0 plus 42 by minus 1 to the power of 4. Denominator is positive, that is positive, so this is positive. And now the final f double prime of, this comes from 1 to infinity. So 1 to infinity, let's take it as 4 itself. So 12 times 4 plus 42 divided by 4 minus 1 to the power of 4. This will be positive and this is positive. So the whole thing is positive. So that means the intervals would be, this would be concave down, this will be concave up, and this would be concave up. Okay, finally the 18th one. F of x is equal to 2 tan x. Again from minus pi to pi. So let's differentiate. F prime of x is equal to 2 times sec square x, which can be written as 2 times tan square x plus 1. Okay, so let's differentiate it once more. F double prime of x gives us, this will be 2 tan x, and tan x is sec square x plus 0. So which gives us 4 tan x sec square x. And again, sec square x can be written as tan square x plus 1, which gives us 4 tan cube x plus 4 tan x. Now let's equate it to 0. What do we get? 4 is common. Take it to the other side. It disappears. So we would be left with tan, and let's take common out. So tan x is common, and we get tan square x plus 1 equal to 0. Which means what? Which means tan x equal to 0, tan square x plus 1 equal to 0. Tan x is sin x by cos x equal to 0, which means sin x is equal to 0, which means x is equal to minus pi, 0 and pi. And here what happens? Tan square x is equal to minus 1, which means sin square x by cos square x is equal to minus 1. This is not possible. Why? Because sin square will always make it positive. This square will make cos square always positive. So positive divided by positive can never be negative. So the intervals are going to be minus pi to minus pi by 2, minus pi by 2 to 0, and from 0 to pi by 2, and finally pi by 2 to pi. Okay, now let's figure out the concavity. F double prime of something in between minus pi and minus pi by 2. So minus 3 pi by 4 is equal to a positive number. F double prime of again something between minus pi by 2 and 0. So minus pi by 4 is equal to a negative number. F double prime of pi by 4 is a positive number, and F double prime of 3 pi by 4 is equal to a negative. So which means this is going to be concave up, concave down, concave up, and concave down. So that is intervals of concavity. That's it. Bye.